So here we have a bullet of mass 0.1 kilos. It's fired at 400 meters a second in a horizontal line. Let's say it's going here in the positive y direction. It strikes a stationary wooden target. So we have this wooden target that's not moving, and its mass is 3. And if the bullet becomes embedded in the wood, find the speed of the compound body after the impact. Okay, well, let's look at the momentum here. We have 0.1 times 400 plus 3 times 0. That has to be equal to the momentum afterwards. Then the bullet's inside the thing, so it weighs 3.1. What do they call it? A wooden target. And obviously if it's inside it, they're both going the same speed. So we should be able to simplify this quickly. 40 is equal to 3.1 V. And if we divide 40 by 3.1, we're going to get 12.9 meters per second. So a similar type of question here. A bullet 0.1 kilo fired at 200 meters a second enters a block of wood which is at rest. So whatever the mass is here, it doesn't really matter so far because we're going to be multiplying it by 0. And the velocity of the joint mass is 10. So now we have m plus 0.1 times 10. This being the v that we calculated in the last question. We're going to end up with 20 is equal to 10m plus 1. 10m is equal to 19, 20 minus 1. So m is equal to 1.9, and that would be in kilograms. This one we're looking for the original speed of the bullet. So we have the bullet of mass 50 grams. Now 50 grams in relation to kilos, well 100 grams is equal to 0.1. So just half of that is 0.05 for the mass, just be careful. So we have 0.05 times u, which we don't know, plus the piece of wood, 1.4 kilos, it's at rest. So afterwards we have 1.5 is the total mass, and it's going 4 meters a second. So we're going to get 0.05 u is equal to 6. U is equal to 6 divided by 0.05. Well, there's 20 of them in 1, so 6, there's going to be 120 of them. So u is going to be equal to 120 meters per second. Question 11, we have a bullet of mass 0.1 fired horizontally into a mass of 2.9. So it becomes embedded. So we're looking at the joint mass here is going to be 3 kilos. So I think we need to work backwards here. If we have mgh plus a half mv squared, I think we'll be able to get the speed. It comes the second speed first. So let's have a look at this. So we have m, which is 3, by g by h, which if we take this line as h is equal to 0, by 0 plus half 3, we don't know this v squared, that's going to be equal to the amount the combined after what's happening afterwards. So how far does it rise here? Let's do a little diagram for how far it rises. This is 20, this is 20, so we're looking for this line along here, this comes down to here. So we can say that we want the risen part, so if we can get this first, we call that x. So 60, 20 and x. So we have adjacent hypotenuse, cos of 60 is equal to a over h. Cos of 60 is a half, so x is equal to 10. So if this one is 10, then this one has to be 10 as well. Actually, I draw that line in the wrong place, didn't I? This is my h equal to 0 line. Just be careful. So they're both 10, so it's risen 10. So the second part of this is my half, it's going to stop. So my second speed is the half mv squared is half by 3 by 0 when it stops. And the mgh part is going to be 3 by g by 10. So what do we end up with here? We end up with 1.5 v squared is equal to 30g. Divide by 1.5 to get v squared is equal to 20g, and 20g is 196. This works out evenly. So v is equal to 14 meters per second. So that's what the speed is. So to go back and find the initial speed now, we have the second speed. We need to go back to our m1u1, m2u2. So I'll just write that down. m1u1 plus m2u2 is equal to m1u2. Although they're embedded now, so it's actually just, we can just add them together. m1 plus m2 times the second speed, which we've just worked out to be 14. So 0.1 by the initial speed, I'll just call it u, plus the 2.9 by the 0 was at rest. That's going to be equal to 2 added together, which is 3 times the 14. So what do we end up with here? 0.1 u is equal to 42. So just multiply by 10. U is equal to 420 meters per second.